As we finish up chapter 4, we're going to take a look at matrices and how we can use them for transformations. So transformation is just a change made to a figure. Some terminology here: the pre-image is the original figure, and then the image is the figure produced by a transformation. So there's 4 types of transformations. You see a translation here, which is called a slide, and a figure slides without it rotating or resizing or reshaping. So the blue slides over to where the gold is. So in just using our terms here, the blue would be the pre-image, and the gold here would be the image. The next one is called a reflection or a flip, and that is a figure is reflected across a reference line. Oftentimes we use the x-axis or y-axis, or even the y equals x line, which is the one that goes through the origin. So y equals x or y equals negative x. Next one's a rotation or a turn. It's rotated about a given point. Oftentimes we use the origin. Then we have dilation twice. We can either stretch it, so it's enlarged, and it still produces a similar shape. And then we also could reduce the size, which is shrinking it. So what we're going to do, we're going to write different shapes. We're going to look at their vertices. We're just going to deal with some basic easy shapes for now, polygons mostly, and we're going to find the points of the vertices, and we're going to put them in what we call a figure matrix. So to write a figure matrix, we put our x coordinates in the first row and the y coordinates in the second row. And so if you look at this one here, we have the point -3, 5. So here's -3 in the first row and 5 is in the second row. X value and y value. And that's how they continue. -2, 2 is this one here. -3, -1, and -4, 2. So that's our figure matrix, and we're going to be using that for these transformations. So the first thing is translation. It's nice and simple. It makes sense to translate. We just add to either the top row, which has to do with the x values, or add to the bottom row, which has to do with the y values. So by adding 4 to each value in the top row, it's going to move it to the right 4. Subtracting 2 from each value in the bottom row, because remember the bottom row has to do with the y values, it will go down 2. So this would be showing a transformation, a translation of the rhombus in this figure here. So let's try it on our own. Write a matrix equation translating triangle EFG 4 units right and 5 units down. Then graph the the image. So what we'll do, first we'll start by writing a figure matrix. So our figure matrix for EFG, let's start with E. This is -4, 1. So remember, we put the x value in the first row, the y value in the second row. F is -2, 3. So -2 in the first row, 3 in the second row, and then G is 1, 0. So there's our figure matrix, and we want to add our translation matrix to this. We want to go 4 units to the right. So that's our x values, so we're going to put a 4 in all 3 spots, so 4 gets added to each of these. And we want to go 5 units down, so it's down, so we want to go negative. So we're going to add -5 to each of the y values. And we can get our image, which will be at 0. -2 and 4 is 2. And 1 and 4 is 5. And then -4, -2, -5. Let's go ahead and graph this. So we have 0, -4, 0, -4. Now that had to do with E, so we can call this E, and we put a little apostrophe here, and we call it E prime. So that was our first value. E went to E prime. Now we're at 2, -2. So 2, -2. That's point F prime, which corresponds to F. And then 5, -5. It's this point here. This is G prime. And we can connect those to make the image. And there we have our image. So translating is pretty easy. Add or subtract values from the x values to shift it left or right. Add or subtract to the y values to shift it up or down. Reflections. So reflections and rotations are going to be a similar idea. So we see here, to reflect, we need to left multiply by the desired matrix. Here are the matrices that we left multiply by. If we want to reflect over the y-axis, you multiply here. If you want to reflect over the x-axis, you multiply by this one. If you want to reflect over the y equals x line, which is this line right here, that's the y equals x line, you multiply by 0, 1, 1, 0. And if you multiply, or if you want to reflect over the y equals negative x line, which is the line coming up this way, you multiply by 0, -1, -1, 0. Here's some other things that you can see here. If you're just changing points, that you can think about switching points. So any point x, y, if you're flipping over the y-axis, if you think through this, flipping over the y-axis, if we wanted to flip h over the y-axis, it will still have the same height. It will still have the same y value. It just will have an opposite x value. So this is at 1, so its reflection, its x value would be -1. And this is at 5, so its reflection would be -5. So we can see any x value goes to the opposite x value, but the y value stays the same. And we could talk through each of these and see why they work. And we'll see a couple, and maybe we'll talk through them as we go. So write the matrix equation reflecting hij, so here's hij, across each line, then graph the pre-image and the image on the same coordinate plane. All right, so over the x-axis, so we're going to flip it over the x-axis. We know we want to left multiply. So we're going to left multiply, which means we put our 1, 0, 0, -1 here. We need our figure matrix, so h. So we're going to multiply it by h, which is 1, 4, I, which is 5, 4, and then j, which is 5, 1. We're going to see these numbers just in a different order or different places. So let's see what happens here. First row with first column, so let's go ahead and put our answer here, down here in blue. 1, 0 with 1, 4. So 1 times 1 is 1, plus 0 times 4 is 0. And first row with second column, 1 times 5 is 5. 0 times 4 is 0. And 1 times 5 is 5. And 0 times 1 is 0. So notice the 0 here. When we have a 0, it was multiplied by the bottom row, so those 3 numbers really didn't have any effect on anything. Now let's go and do the second row with the first column. 0 times 1 is 0. So now we're going to notice 0 is going to be multiplied times each of the first rows. So you can really think through this and get this pretty quickly. So, and then -1 times 4. Our next one, 0 times 5 is 0. And -1 times 4 is -4. And the last 0 times 5 is 0. And -1 times 1 is -1. So we have this matrix. Let's go ahead and add these things. I got this a little bit clumped together. So we have 1, 5, 5, same as our original. So the the x values don't change. And then -4, -4, -1. And that gives us our image. So let's graph both of these. So we already have it here, so we know what 1, 4 is H, 5, 4 is I, and 5, 1 is J. So that is our pre-image. And then we'll graph the image. We got 1, -4, so 1, -4, 5, -4, and 5, -1. So we see it flipped over the x-axis. And looking at the values, the x values stayed the same and the y values were opposite. And that's what this is saying here, this little row. Next one says we're going to flip it over the y equals -x line. I'm going to kind of use this bottom space here. So we're going to use 0, -1, -1, 0. 0, -1, -1, 0. And we want to multiply that by our matrix, 1, 5, 5, and 4, 4, 1. And let's multiply that and see what we notice. So, all right, let's talk through this. 0 times 1, so our first number is 0, which as we work through these, 0 is going to be multiplied by 1, then by 5, then by 5. So our first row really doesn't have any effect because they're going to be multiplied by 0, and then -1 is going to be multiplied by this bottom row. So 0 times 1 is 0, and -1 times 4 is -4, so we just have -4. 0 times 5 is 0, -1 times 4 is -4. So really what's happening here is we're just grabbing the opposite of the bottom row, which is interesting because it was in the bottom, 4, 4, 1, but now 4, 4, 1 is in the top, but negatives. So let's see what happens here. -1 times 1 is -1, but then we have this 0 that's going to be multiplied by 4, so that's 0. -1 times 5 is -5, plus 0 times 4, and -1 times 5 is -5, plus another 0. And so there is the image. And we can graph both of these. Our first one was 4, 1, 5, 4, and 5, 1. That's our pre-image. And then the image is -4, -1, -4, -5, and -1, -5. And that was flipped over the y equals -x line. So let's just show what that line is. Never did draw it in there. So it's flipped over. This is the y equals -x line. So it goes through 0, the origin, y-axis of 0, and then slope of -1. So that's flipped over that one. So that is reflecting. You have these 4 different reflection lines that we can work with. Now we have rotations, so rotating. And so this is telling us we can rotate 90 degrees. This should be 180 degrees. Mistake there, so 180. Rotating 270 and rotating 360 degrees. So rotating 360 degrees, you're just going to come back to the exact same thing. So you actually just multiply by the identity matrix. To rotate about the origin, left multiply by the desired matrix. Write the matrix equation rotating triangle KLM 90 degrees counterclockwise around the origin. Then graph the image. So we have the pre-image KLM. And we're going, once again, this is a left multiply. We want to rotate 90 degrees. So we're going to multiply by 0, negative 1, 1, 0. Our matrix here, let's start with K, so we have 0, negative 1. L is 3, 0, and M is 3, negative 1. If we think through this, again, we have a 0 first, so 0 times 0 is 0. Negative 1 times negative 1 is 1. Negative 1 times 3. Sorry, 0 times 3 and negative 1 times 0. So we actually get a 0 here. And then 0 times 3, which is 0. Negative 1 times negative 1, which is 1. So let's think through this. What happened here? Well, my second row became the first row, but it's negative. That's because, so first row didn't matter, change the second row to negative. Now we do 1 times 0 is 0. 0 times negative 1 is 0. 3 plus 0. 1 times 3 times 0 is 3. So what happened here? This one just came right here. And so we can graph that image. Let's graph that in blue. We have 1, 0. That's K prime. We have 0, 3. That's L prime, and 1, 3. I'm sorry, I said 0, 3. We have 0, 3, which is up here. So that's L prime. And we have 1, 3, which is M prime. So there is the image, which rotated that thing 90 degrees counterclockwise. All right, here we have dilations. So to dilate with respect to the origin, you scale or multiply the matrix by the desired dilation. See here that to make an image smaller or reduce the image, you're going to multiply by a fraction or something between 0 and 1. To get the exact same shape, you would multiply by 1. And to enlarge the image, you would multiply by something larger than 1. So here we have an example. Write a matrix equation representing a dilation with a scale factor of 2.5, and then graph the image on the coordinate plane. So we want to go ahead and write a matrix for this figure here. We will start with n. So here we have n is negative 2, 2. O is 0, 3. P is 0, 1. Q is negative 1, 1. And R is negative 1, 2. So there is our figure matrix. We want to enlarge it. So we're going to scalar multiply by 2.5, which is pretty easy to do. We can just multiply 2.5 times each element. So we're just going to work our way through here. 2.5 times negative 2 is 5, times 0 is 0, times 0 is 0, times negative 1 is negative 2.5, times negative 1 again, so we got negative 2.5, times 2 is 5. Somehow I missed my negative here. 2.5 times negative 2 was negative 5. Back to this one, 3, that's 7.5. These are both 1, so 2.5 times 1 is just 2.5. And our last one is 2.5 times 2, which is 5. Decimals got lost here, my numbers, some of them. And so we want to graph this. N prime will be at negative 5, 5. O prime is 0, 7.5. P prime is going to be at 0, 2.5. Q prime, negative 2.5, 2.5. And then R prime is going to be at negative 2.55. We can connect these, and we get, see, we get the same shape, but larger. And there is the image. And that is using translations, rotations, reflections, and dilations.